Descriptive Statistics. So in this topic, we are expected to learn the importance of measurement of assessment. So let's start. These are the subtopics that I am going to discuss with you. I hope that we can learn from these subtopics. Why is measurement important? So today I am going to give you a brief discussion about the importance of measurement. Why is measurement important? So for me, I personally believe that measurement is important to gain accurate and precise data or results. Both measurement and evaluation are important parts of the instructional process, a sequence of procedures conducted before, during, and after teaching. So psychoeducational assessment using standardized instruments historically has been applied in the educational decision-making process. So when we say psychoeducational assessment, it is an evaluation conducted by a psychologist to determine whether a child or teenager has developmental and learning challenges. It also provides an in-depth exploration of a child's strengths and weaknesses compared with their peers, allowing parents to gauge their child's development. To properly use standardized instruments, one must understand the test selection criteria, basic principles of measurement, administration techniques, and scoring procedures. Okay, so when we say standardized instruments, these are tools that measures a specific skill, quality, or characteristic or related group of these attributes. When using a standardized instrument, the same information is gathered from every subject in the same form, making comparison among individuals. So the careful interpretation of these results relies on these abilities. Thus, research that questions the assessment competence of special educators and other professionals is frightening because the educational future of so many individuals is at risk. So these are the definitions of psychoeducational assessment and the standardized instruments. So moving on forward, are several studies in the early 1980s made note of the typical types of mistakes made by teachers, administrators, psychologists, and other professionals in the field of special education. Research that pointed out the occurrence of such errors heightened the awareness of importance of educators needing a basic understanding of the measurement principles used in assessment. So some of these researchers are Algozzini and Isildicky. 1981, 1981 found that professionals identified students as eligible for special education services when the students' test scores were within the average range and relied instead on referral information to make decisions. And also researcher Webner 1988 to 1989 indicated that professionals made errors in the diagnosis of learning disabilities more frequently when scores were reported in percentiles. Okay, so this reflects inadequate understanding of data interpretation. So McLaughlin, 1985, advocated training for special educators up to the level of superior practice rather than only minimum competency in psychoeducational assessment. So since there are errors in conducting the assessment, McLaughlin advocated for the superior practice of teachers, and it is very important for all teachers, not just in special education, but also in general education teachers. It is because we have to give our students the best quality education. So the standards for educational and psychological testing, AERA, APA, and NCME 1999, warned that when special educators have little or no training in the basic principles of measurement, the assessment instruments could be misused, which is true because when we assess a child, we must know the basic rules and understandings of our purpose because in that case the results of a child's condition might be misunderstood. Much of the foundation of good practice in psychoeducational assessment lies in a thorough understanding of test reliability and validity, as well as the basic measurement principles. So it was in 1986 when Warden and Balcarce found that most teachers believed that understanding basic principles of measurement was an important aspect of classroom teaching and evaluation. So although there are revisions in policies governing the provision of special education services, thorough and effective assessment of students by members of multidisciplinary team is integral to the team's decision making. So it was in 1986 when they found out that the basic principles of measurement was an important aspect of classroom teaching and evaluation. So let us move forward from our next topic, which is getting meaning from numbers. Okay, so wait. When you administer any test, the first step in scoring is almost always will be to calculate the number of correct items the student obtained. For example, if a student took a 20 question spelling test in your class, the first thing you would do is determine how many words the student spelled correctly. This score is known as the row score. So any teachers who scores a test, either published or teacher made, will subtract the number of items a student missed from the number of items presented to the student. This number, known as the row score, is of little value to the teacher unless a frame of reference exists for that number. So, a frame of reference is a set of ideas, conditions, or assumptions that determine how something will be approached, perceived, or understood. So, okay. The frame of reference might be a national sample of students the same age who attempted the same items in the same manner on a norm reference standardized test. Okay, what by mentioning norm reference test, it is a test designed to compare an individual student score with a national average. With the national average. Okay, wait. In all cases, teachers must clearly understand what can and cannot be inferred from numerical data gathered on small samples of behaviors known as tests. So this topic is very very short. I just summarized it and I simplified it so that you guys will understand. Okay, so let us move forward from our next topic, which is the review of numerical scales. Okay, so review of numerical scales. Numbers can denote different meanings from different scales. So the first scale is the nominal scale or named variables. The nominal scale consists of numbers used only for identification purposes, such as student ID numbers, numbers on race cars, and cell phone numbers. The scale that has the least meaning for educational measurement purposes is the nominal scale. So The nominal scale is also categorizing things. It just it names object, it categorizes an object, it only identifies an object. That is the main purpose of a nominal scale. So note that numbers on the nominal scale function like names. It can't be used in a mathematical operation. So the nominal scales can't be used in a mathematical operation because its purpose is for identification only. It functions like names. It has no numerical value. Next is the ordinal scale. When numbers are used to rank the orders of objects or items, those numbers are said to be on the ordinal scale. For example, um, these numbers cannot be used in mathematical scale operations. I know, no, I'm confused. So, the first, for example, the example of ordinal scale is the first, second, and third person in a competition, a military rank, and a student's average. So, the ordinal scale here is, is to identify and to order the objects or variables. This scale, the numbers have the quality of identification and indicate lesser or greater quality. So the object here is being named and it is being ordered for like this, like the first example, the first, the second, and the third person in the competition. The first runner-up, the second runner-up, and the third runner-up. So next is the interval scale. Interval scale here is named, it is ordered, and has proportionate interval between variables. So numbers that are used for identification that rank greater or lesser quality or amount and are equidistant. For example, the temperature, IQ test, and voltage. So the temperature here, for example, you have the um, 38 degrees Fahrenheit at, yeah, 38 degrees Celsius, and yesterday you have 48 degrees Celsius. So the 10 degrees Celsius here, it doesn't mean nga it means that you are hotter than now than you have high temperature now than yesterday because of the 10-degree interval. Wait. Okay, so this scale, the numbers have the quality of identification and indicate lesser or greater quality. For example, 66 IQ, it doesn't mean that it is the 25% IQ, 25% IQ. And I don't know if it was a percentage, but if you have a 25 IQ, if your IQ is 25, then it doesn't mean that you are four times um you are 4 times lower than the 100 IQ, than those who has 100 IQ test results. So, so in the ratio scale, it is named, ordered, proportionate interval between variables, and can accommodate absolute zero. Numbers on a scale are equidistant from money in your checking account, the age, and the weight. So, for the amount of money in your checking account, if you check your account and you have a zero balance, it means that you have zero money, zero balance. You have you have nothing in your account because it can accommodate ratio scale can accommodate absolute zero. So it is named, it is ordered, money is named, ordered, and has proportionate interval between variables, and it has it has a meaning of absolute zero. So note that it can be used in all mathematical operations, allow for direct comparisons and mathematical manipulations. So here are the 4 scales of measurement. Nominal scale, which is the numerical scale that uses numbers for the purpose of identification. Ordinal scale, numerical scale in which numbers are used for rankings. Interval scale, a scale that uses numbers for ranking in which numerical units are equidistant. Ratio scale, numerical scale with the quality of equidistant units and absolute zero. So here, to check your understanding, I want you to answer only the letter. And I will give you 2 minutes to answer this. I will set a timer here in my phone. Okay, you start answering now. Okay, so time's up. I hope that you answered it. Your answers. I hope that you answered it well. You just put your answers on the chat box. So, descriptive statistics. When assessing a student's behavior or performance for the purpose of educational intervention, it is often necessary to determine the amount of difference or deviance that the student exhibits in a particular area from the expected level for the student's age or scale. By looking at how much difference exists in samples of behavior, educational decision makers and parents can appropriately plan interventions. Okay, it is because when we determine the amount of difference or deviance, then it is easy for us to know or accommodate the needs or the capabilities of a child. So next, many derived scores obtained meaning from large sets of data or large samples of score by observing how large sample of student performed as well as the group, better than the group or not as well as the group. A raw score may have meaning when it is composed with previous students' performance, or it may be used to gain information from another set of scores called derived scores. So, a raw score that you have gathered from your students after the assessment, you cannot see the results if you will not compare it with the other students who has the same situation or learning developmental and learning difficulties, because that is the time we will know their strengths and weaknesses. So the derived scores here are scores obtained by using a row score and expectancy table. So the expectancy table is it is like a standard uh, you know uh, you know uh, rubrics or just a scoring table which you will uh, base your um, base your gathered data after comparing, and that is when the derived scores are found. Okay, so derived scores may be scores such as percentile ranks, standard scores, grade equivalents, age equivalents, or language quotients. So the standard scores are derived scores that present equal units, also known as linear scores. As the name implies, these are statistical operations that help educators understand and describe sets of data. Large sets of data are organized and understood through methods known as descriptive statistics. So the descriptive statistics are statistics rather used to organize and describe Data. Okay, I have here some example of some definition of descriptive statistics. So these are numbers that are used to summarize and describe data. The word data refers to the information that has been collected from the experiment, a survey, a historical record, and assessment. So there are a lot of there are a lot of um, kinds of descriptive statistics here. So the expectancy table, wait a minute. So the expectancy table showing the relationship between two tests. So the expectancy table pala is ito pala yung ginagamit natin para ma-compare natin ang dalawang scores. And um, the scores that are gathered after the expectancy table, that is the derived scores. So that's all for today. I that's all that I will that's all for my topic, guys. Yun lang talaga ang part ko. So, I am not a math expert. I really don't know anything about math. I apologize. I apologize if I had um, misunderstand the misunderstood the contents or and not explain it very effectively to you. And thank you all for listening. God bless.
All right, so to continue with this unit's topic, we will now jump to the measures of central tendency. So if you can still remember, if you can still recall, we already tackled this when we were still in junior high school, and we also had a review about it. Was really not a review because statistics was part of our curriculum. It was our subject, and statistics is really it is really undeniable that statistics was very helpful in our research, especially in quantitative research. So to recap, measures of central tendency is one way of organizing and describing uh, the data to see how the data fall together or cluster. So the word cluster is your clue here so the word cluster is your clue here para makadetermine mo nga ang measures of central tendency siya. So basically, measures of central tendency are statistical methods for observing how data cluster around the mean. So moving on, the most common type of distribution which is used in assessment is called a normal distribution. This helps in interpreting of assessment data. So, how? Normal distribution represents the way test scores would fall if a particular test were given to every single student of the same age or in the same grade in the population for whom the test was designed. So, this is how a bell curve looks like. So the scores would fall in the shape of a bell curve. A very large number of the students tested are represented by all of the scores in the middle or the hump part. If you can see my cursor moving here, mo ni ang hump part. So, because fewer students obtain extremely high or low scores, their scores are plotted in the extreme ends of the score. So, mo ni ang extreme ends dito. The distribution is symmetric or equal on either side of the vertical line. So, when we say vertical line, it means varog. So, yeah, I think it's a bit funny. So, varog means vertical line, this one, and the horizontal line is ang line nga naghigda. So, if na po mga students nga kanang maglibog kung unsay horizontal line and vertical line, you can teach them that. So now let us move forward to the next topic, which is the average performance. So the teacher must determine what is considered average for a specific set of data, just like how the other students performed and what scores indicate average performance, what score denotes excellent performance, and what score signifies poor performance. So one way to look at a set of data is to rank the scores from highest to lowest. Thus, frequency distribution will be utilized. So paano ba? By counting how frequently each score occurred. So, mao ni ang gitawag na to nga frequency distribution. So, this one is clearly defined as a method of determining how many times each score occurs in a set of data. So, let us take this set of tallied data as an example. So as you can see, the data is listed from highest to lowest. So 100 being the highest score down to the lowest score, which is 60. So you can see here the tally na ang nakakuha ng 100 na score ay isa lang. So ang frequency ay isa lang din. So dito, 1 lang din yung inilagay. So 99, isa lang din. Sa 98, dalawa. So on and so forth. So as you can see here, 5 and 5. So 10 estudyante ang nakakuha ng score na 88. So ano bang tawag dyan? So another way to look at the data is to determine the most frequently occurring score or the mode. So the mode can give the teacher an idea of how the group performed because it indicates the score or performance that occurred most often. So the mode for data set A, what is the mode? The most occurring, the most frequently occurring score, di ba, 88. So the mode for data set A was 88 because it occurred ilan? It occurred 10 times. Alright. So, anong tawag dito na type of distribution? So, this is what we call the unimodal distribution because it has only one most frequently occurring score. So, 88 lang ang pinakamarami at 88 lang ang 10. So, when a set of data has two most frequently occurring scores, it is known as the bimodal distribution. So, di ba, if bicycle, yung bike, dalawa yung wheels, dalawa yung gulong. So, kaya bimodal, dalawa ang mode. Bimodal distribution, dalawa yung mode. Unimodal distribution, isa lang yung mode. So, if ang 89 ay may 10 estudyante na nakakuha ng 89 na score, tapos 10 sa 88 at 10 din sa 89. Meaning, bimodal na distribution na yun. So, if here's a multimodal distribution, there are 3 or more frequently occurring scores. It is known as the multimodal distribution. 3 or more. So, for example, 89, 88, and 82, pareho silang may 10 na estudyante na nakakuha ng ganyan na score, may 10 estudyante na nakakuha ng 89, may 10 estudyante na nakakuha ng 88, may 10 estudyanteng nakakuha ng 82. So, tatlong scores ang may pareho na frequency. So, meaning doon, tatawagin natin siya na multimodal distribution. So, a clear representation of the distribution of a set of data can be illustrated graphically with a frequency polygon. So, what is a frequency polygon? A frequency polygon looks like this. It is a graph with test scores represented on the horizontal axis, which is the horizontal axis, which one? Here or here? So, horizontal axis is the one na naghigda. So, nandito yung test scores. So, the 100, 95, 55, ganon. And the number of the occurrences or frequency, kung kapila siya nagbalik-balik, kung pila ka estudyante ang nakakuhaan nga score, meaning na diri sa vertical axis or the varog axis, the varog line, di ba? So, kung babalik tayo dito, sa 100, ang nakuha ng 100 na score, ay isa lang. So, isa lang din, di ba dito? 100. Look at my cursor. So, 100. So, ilang estudyante ba ang nakakuha ng 100 na score? Di ba isa lang? So, titignan mo yung vertical na line dito, 100. 100 dito, and then isang estudyante. So, dito ka magpa-plot, and then susundan mo lang yung nakatali na score para makagawa ka ng isang frequency polygon. So, for example, yung mode natin na 88, 88, di ba, 10 estudyante ang nakakuha ng 88 na score. So, imong pangitao ng 88 na score. So, before 90. So, before 90, here, dito. And then, 10 estudyante ang nakakuha ng 88 na score. So, titignan mo yung vertical na line. O, dyan, 10. So, here. Ganun lang. It is very simple. So, another method of, so let us move forward. So, another method of determining how the group performed is to find the middlemost score or the median. After the data have been rank ordered, the teacher can find the median by simply counting halfway down the list of scores. Alright, so I'm gonna share this tab. So yeah, in a set of data with an even number of scores, the median is the middlemost score even though the score may not actually exist in the set of data. So, sasabihin nyo, di ba, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, 10 sila, 10 silang lahat. So, yung middlemost score ay dalawa kasi even number yung score. So, ang middlemost niya ay 85 and 83. So, tatanungin nyo, paano yun? So, you're just going to add up the two middlemost scores. So, 85 plus 83, and then you're going to divide it by 2. So, 84. So, okay lang na wala sa nakatali na score yung median. Alright. So, if odd number naman, imo rang pangitaon kung saan yung middlemost na score. So, ito, 89, I mean 79 ang middlemost. So, ganyan lang. It is very easy to determine the median. Although the mode and the median indicate how a group performed, these measures of central tendency do not accurately describe the average or typical performance. One of the best measures of average performance is the arithmetic average, or the mean of the group of scores. So the mean is calculated as a simple average. So you're just going to add the scores and divide by the number of scores in the set of data. Okay, let's take this one as an example. Wait. All right, that one. So how are you going to get the mean? So you're just going to add everything up. You're going to hahanapin mo lang yung sum. So it really doesn't matter if it is not arranged from highest to lowest, because it is just the average of the set of data. So you're going to add 90, 80, 75, 60, 70, 60, 65, 80, 100, 80, and 80. So the total of that is 780. So you're going to divide it by 10. So yung mean mo ay 78. So, so much for that. So in addition, extremely high or low scores can render mean misrepresentative of the average performance of the class. So using measures of central tendency is one way teachers can determine which score represents an average performance for a particular group on a particular measure. This aids the teacher in monitoring student progress and knowing when a student is performing well above or well below the norm or the average of the group. So, the mean can be affected by an extreme score, especially if the group is composed of only a few students. So, a very high score can raise the mean, whereas a very low score can lower the mean. So, that's just the basics of the measures of central tendency, which includes the mean, median, and the mode. So let's take a short recap. So the mean is the arithmetic average of a set of data. So you're going to sum up all the data and then divide by kung ilan yung data, 'di ba? So let's move to the median. The median is a middlemost score in a set of data. So the mode is the most frequently occurring score in a set of scores. So we have here different types of distribution. So we have here unimodal, bimodal, multimodal. Unimodal kapag isa lang yung mode sa isang set. Bimodal kapag dalawa yung modes sa isang set. And multimodal if tatlo or higit pang modes ang makikita mo sa isang set. So, Subtanra, if you have questions, don't hesitate to raise your hands or comment on the chat box. So, before we move forward to the next topic, let us answer this short activity for uh 10 minutes. All right. So you're just going to find the mean, the median, and the mode for each set of data. So I also added here the type of distribution. So this is 2, 4, 6, 8. So 8 points all in all. So if we're going to add activity to an activity 1, we have 13 points, 5 and 8. 13 points for today. So, do you have any questions, clarifications? So if none, oh, your answers will be submitted sa comment section lang, sa comment box. So, wala nang question. So, the timer starts now. Alright, you only have 3 minutes left to answer the activity. Alright, last 1 minute. So turn in your answers already in the chat box. Thank you. Five, four, three, two, one. Alright, time's up. So, yep, that's the time. So, I hope you all turned in already your answers. So, I have here the answers of this activity, but I will not give it to you because there are still people who are not able to answer this activity. Alright, so moving forward, we have here the next topic, which is the measures of dispersion. So special because special educators must determine the degree uh, or amount of difference exhibited by individuals in behaviors, skills, or traits, they must employ methods of calculating difference from the average or expected score, just as measure of central tendency are used to see how sets of data cluster together around an average score. Measures of dispersion are used to calculate how scores spread from the mean. So, if we are going to compare measures of central tendency from measures of dispersion, measures of central tendency is just basically statistical methods for observing how data cluster around the mean. And on the other end, measures of dispersion are statistical methods for observing how data spread from the mean. So, the way that scores in a set of data are spread apart is known as the variability of the scores, or how much the scores vary from each other. So when scores fall very close together and are not widely spread apart, the data are described as not having much variability or variance. So variability describes how scores vary. Variance describes the total amount that a group of scores varies in a set of data. So this would tell us that variability only describes and variance ay yung nag may nag-compute may computation na nangyayari, ganon. And then the range here is the distance between the highest and the lowest scores in a set of data. So let us compare the following two sets of data. So we have here two different sets of data, data set I and data set J. So pareho lang sila na yung median score nila is 75, here 75, but they are very different sa highest score and the lowest score. So an easy way to get an idea about how the spread is to find uh, the range of scores. So let's move here. All right. So the range is calculated by subtracting the lowest score from the highest score. Am I sharing the right thing? All right. So yun, the range is calculated by subtracting the lowest score from the highest score. So we have here the highest score of data set I. The highest score is 100 and its lowest score is 50. So if we're going to find the range of the set of data, we are going to subtract 100 from 50. 100 minus 50 is equal to 50. So on the other hand, here on the right side, data set J, its highest score is 98 and its lowest score is 72. If we're going to subtract that from one another, 98 minus 72 is equal to 26. Alright, so yan yung range natin. The range for set J, here sa right, is about half of that set of set A. It appears that set I has more variability than set J. Look at the sets of data again. Both sets have the same median and the same mode, yet they are very different in terms of variability. When the means are calculated, it means that the data are very similar. Set I has a mean of 77.15. Take note of that. Set I has a mean of 77.15 and set J on the other hand has a mean of 77.05. 'Di ba? Very close lang sila. 77.15 and 77.05. So by using only measures of central tendency, the teacher may think that the students in both of these classes performed in a very similar manner on this task. Yet, one of one set of data has approximately twice the spread or variability of scores. In educational testing, it is necessary to determine the uh, deviation from the mean in order to have a clear picture of how students in groups such as these performed. So, by calculating the variance and the standard deviation, the teacher can find out the typical amount of difference from the mean. By knowing this typical or standard deviations from the mean, the teacher will be able to find out which scores are significant distance from the average score. Alright, so let's go back to the slides. So let's now move forward to the standard deviation. So to find the standard deviation of a set of scores, the variance first must be calculated. So the variance can be described as the degree or amount of variability or dispersion in a set of scores. Looking at the set of, let's not include, let's not go back na lang sa set I and set J. Before we continue, let us first define what standard deviation is. So, standard deviation is a unit of measurement that represents the typical amount that a score can be expected to vary from the mean in a given set of data. So, here are the steps in calculating the standard deviation. So, for the step 1, you're going to calculate the amount of distance of each score from the mean. So, you're just basically going to subtract the mean for the set of data from each score. So we have here the highest score, which is 100. And then the mean of this set is 77.15. So basically, you're just going to subtract 100 from 77.15. So that will, ang answer ana niya is 22.85. Right? So, mura gyapon asa 90 sa sunod nga mga scores, you're just going to subtract 77.50 kanang you're just going to subtract it from 77.15 which is the mean. So mo ni siya mean is siya sa ani nga set kaning 77.15. So kanay diri mag negative na gini siya kay if you're going to subtract 75 by the 77.15, it is equal to negative 2.15. So let's move forward to the next step. Step 2. Find the square of each of the difference scores found in step 1. So you're just basically going to multiply each difference score by itself. So a square. So yung 100 minus 77.15 is equal to here 22.85, 'di ba? And then sa step 2, you're going to multiply it by itself. So 22.85 times 22.85. So ang answer ay 522.1225. Yan. Yan yung gagawin mo sa lahat ng scores. You're going to multiply by itself. Yan. So, di ba, as you can see, the negative kanina is now positive because any number which is multiplied by, if you're going to multiply negative times negative, yung answer ay magiging positive. So, moving forward. Step 3. Find the total of all the squared score differences. This is called the sum of squares. So, the sum of squares yung tawag sa ito. If you're going to add everything, you're going to add everything, yung answer sa squared, magiging 3,488.55. And then sa step 4, you're going to calculate the average of the sum of squares by dividing the total by the number of scores. So divide the sum of squares by the number of scores. So ito 20 lahat sila, 'di ba? If you're going to count 100 up until 50, 20 yan. And then in step 4, sinasabi dito na sum of squares by the number of scores. So 3,488.55 divided by 20 is equal to 174.4275. All right. Gets ra? If you have questions, please don't hesitate to uh, type it in the chat box. So therefore, the variance for data set I is 174.4275. Pero for decimal places naman ni siya, mo kuan na lang ta na 2 decimal places. So, since 7 man ang tapad sa 2, so round up na lang ang 2 to 3. So, ang answer na niya kay mo ng 174.43 ang iyang variance. So, once the variance has been calculated, only one more step is needed to calculate the standard deviation. The standard deviation helps the teacher determine how distance from the mean is typical and how much is considered significant. So, here is the step 5, which it will tell us that the standard deviation of a set of data is the square root of the variance. So basically, we're just going to ikuha na dyan na to sa calculator kung unsa ang square root ana niya na number. So since our variance is 174.43, if i-square root na nato siya, ang mogawas is 13.21. So the square root of the variance for data set I is 13.21. So therefore, any test score, right here. Therefore, any test score that is more than one standard deviation above or below the mean score, either 13.21 above the mean or 13.21 below the mean, is considered significant. Look at the data set I here. The test scores are more than one standard deviation above the mean, which is, you can still remember yung mean natin is 77.15. So, the test scores that are more than one standard deviation here, so ito, dito, are the scores 100, 98, 95, and 91. On the other end, here, the scores that are more than one standard deviation below, ito, dito, one standard deviation below, the mean are, I mean, one standard deviation below the mean are scores 51 and 50. So these scores represent the extremes for this distribution and may well receive the extreme grades for the class as figure 3 illustrates the distribution of scores in dataset I. So basically that's just everything for standard deviation. So if you have questions, please don't hesitate to type your questions sa comment box. So class, if kaning dire ang iyang score kay 91, 95, 98 niya 100, meaning A jud ang makuha niya ana. A nga, what we call this? Basta A, and then diri kay fail siya if kanang mo lapas na siya below sa 64. So are we all clear? Nasabtan ra ba? So if you don't have questions, I will give the virtual floor to Julian Amistoso. Thank you for listening.
In a normal distribution, the standard deviations represents the percentages of scores. We already know that normal distribution is symmetrical and has the same number representing the mean, median, and mode. More than 68% of scores fall within one standard deviation above or below the mean. To understand the relevance of standard deviation, we have to keep in mind that An IQ score or more than 2 standard deviations below the mean is one of the criteria for diagnosing mental retardation. And also, the American Association of Mental Retardation or AAMR classification system allows additional flexibility by adding 5 points to the minimum requirement. That is, the student within the 70 to 75 IQ range may also be found eligible for services under the category of mental retardation if they are adding supporting data. Below you can see the figure 3.4, the percentages of population that fall within standard deviation units in a normal distribution. Now let's proceed to the mean difference. What is mean difference? It is a standard statistic that measures the absolute difference between the mean value in two groups in a clinical trial. It estimates the amount by which the experimental intervention changes the outcome on average compared with the control. Many tests that have been used historically to diagnose disabilities, such as mental retardation, have been shown to exhibit mean differences. Mean differences exist when a cultural or linguistic group's mean or average score differs from that of the majority of the population. Now, let me share to you the formula on getting the mean difference. So as you can see in the attached photo, that is the formula on getting the mean difference. So it is mean difference is equal to sum of first variable over n minus sum of second variable over n, where first variable is mean of group 1 and the second variable is mean of group 2 and n is the sample size. So now let's have an example, a problem statement. No worries, classmates. This is just an example. So there are two dance groups whose data is listed below. Find the mean difference between these dance groups. So as you can see in the attached photo, the data in group 1 are 3, 9, 5, and 7, while in group 2 5, 3, 4, and 4. So let me share to you on how to solve and get the mean difference in this problem. So first, as you can see, the data on both groups 1 and 2 are added separately. Then after adding the data of both groups, i-divide naman natin ito sa sample size. At yun na, nakuha na natin ang mean difference ng problem. At ito ay 2. Diba? It's very easy. At ngayon, alam na natin kung paano kunin ang mean difference. Dadako naman tayo sa skewed distribution. So, skewed distribution, when small samples of populations are tested or when a fairly restricted population is tested, the results may not be distributed in a normal curve. So distributions can be skewed in the positive or the negative direction. So distribution can be skewed in positive or negative direction. When many of the scores are below the mean, the distribution is said to be positively skewed, will resemble the distribution shown in figure 3.5. So look at the figure 3.5 in the left side. So now, notice that the most frequently occurring scores or mode are located below the mean. So, tingnan nyo ang figure 3.5. And as shown in figure 3.6, notice that the mode and the median scores are located above the mean, when a large number of the scores occur above the mean. the distribution is said to be negatively skewed. So, tingnan niyo ang figure 3.6 sa right side. Yan. 'Di ba nakikita niyo ang difference nila physically? Like, if it is called negatively skewed, nasa right. Pa-right ang kaniyang mahabang tail. And pag sinabi naman nating positively skewed, nasa left side ang kanyang long tail. So, alam kong hindi niyo masyadong naintindihan, kaya may video akong ipapakita sa inyo.
This is Stephanie from statisticshowto.com, and in this video I'm going to briefly show you about skewed distributions. This is a normal curve and it is completely symmetrical, so there is no skew. These ends are called the tails of the distributions, and if one of these tails was longer, then the distribution would be skewed. On the left, this is a left skewed distribution, and on the right, this is a right skewed distribution. One thing that is a little confusing is that the skew does not refer to the peak. So when you're figuring out skewness, don't look at the peak of the distribution, look at the tail. This is a long left tail, so it is left skewed. This one to the right has a long right tail, so it's right skewed. This is also called positive skewness because the tail is on the positive end of the number line. And this one over here is negatively skewed because the tail is tending towards the negative on the number line. Here's another example of the skew distribution from the New York Times. And as you can see, this is a negatively skewed or left skewed distribution. A couple of points about the mean, the median, and the mode. In a left skew distribution, the mean is going to be to the left of the median. And in a right skew distribution, the mean is going to be to the right of the median. That's how to tell the difference between left skewed and right skewed. Check us out at statisticshowto.com for more videos and articles on everything elementary statistics.
According to Harvey 2000 and Buckert and Harvey 2002, the fundamental reason for skew is that normal distribution analysis wrongly calculates expected returns and risk in both developed and emerging markets. Skewness is the significant risk factor. Okay, when selecting norm reference test, we special educators must take care to read the test manual and determine the size of the sample used in the norming process. Tests developed using larger samples are thought to result in scores that are more representative of the majority population. So, reminder, skewness can be negative, positive, zero, or undefined. But a normal distribution has a skew of 0. So, types of scores. Percentile ranks and z-scores provide additional ways of looking at data. So, percentile ranks arrange each score on the continuum of the normal distribution. So, the extreme scores are ranked at the top and bottom. Very few people obtain scores at the extreme ends. So, next, percentiles range from less than 1% to 99.9%, with 50 being the average. So a person who scores at the extremely high end of a test may be ranked near the 99th percentile. This means that he or she scored as well as or better than 99% of the students of the same age or in the same grade who took the same tests. Next is a person who scores in the top fourth would be above the 75th percentile. In other words, the student scored as well as or better than 75% of the students in the particular age group. So, for example, Jessie's obtained a percentile rank of 42. So this means that Jesse performed as well or better than 42% of children his age on the test, or 42% of children Jesse's age scored at or below Jesse's score. So, see the attached photo below. That is the descriptors for percentile rangers. With a continuation of types of scores, first, if we have an average of 50 and standard deviation of 10, that is called t-scores. We are using t-scores. So, t-scores are used in some exams to interpret test results. So, t-scores have a 50-point average and a 10-point standard deviation. A t-score of 60 represents one standard deviation above the mean, whereas a t-score of 40 represents one standard deviation below the mean. Next is the standard 9. In short, STA9. It is a method of scaling test scores on a 9-point standard scale with a mean of 5 and a standard deviation of 2. It can be used to convert any test score to a single-digit score. Like z-scores and t-scores, STA9s are a way to assign a number to a member of a group relative to all members in that group. So lastly, the deciles as a quantitative method of splitting up a set of ranked data into 10 equally large subsections. Scores are divided into 10 groups, 10 for the lowest group, 100 for the highest. So each group represents 10% of the obtained scores. It is used to categorize large data sets from the highest to lowest values, or vice versa. A decile is a form of a quantile that divides a set of observations into samples that are easier to analyze and measure. As you can see below the photo, it is the relationships among the different types of scores in normal distribution. In this chapter, the descriptive statistics, students are assessed through collecting data that is utilized to make educational decisions. So, educators must know how to correlate numbers with specific levels of achievement and how to use statistics to compare one student to a national sample when interpreting data. So the concepts of the measures of central tendency and measures of dispersion are useful for test interpretation. So malaki talaga ang tungkulin ng descriptive statistics sa pagkuha ng datos sa mga students.
So, do you have any questions? Please don't hesitate to comment down your questions sa chat box. So, if none, thank you everyone for listening and thank you for your active participation since the beginning of our presentation. Thank you and God bless.